Okay, so we're still looking through module 1.2, and this is going to end up being part 2. Now this is a continuation of the notes that you currently took, so you're going to flip to the pages that refer to conversion of units, and so we're going to do 2 slides there, and then we're going to be discussing the in-class worksheet that you were given that had 2 sides on it. One side was proportions and ratios, and then the other side was unit conversion. And then we'll look at those two and kind of wrap this up. Now, as we kind of move through this, if you look at this sheet here, it's practice and problem solving modified. So we want to look at 2 proportional figures, and we have those here. We have A and we have B. These are our 2 proportional figures. One has a side length of 2 meters, the other one is 4 meters. This smaller one, figure B, has a side length of 1 at the top or on the side, and then kind of unknown here at the bottom. Now, if I was to tell you that rectangle A's width is 4 meters and its height is 2 meters, write a ratio of the height of rectangle A. So the idea here is that we're comparing those two things. We're comparing its width to its height. And so the idea is that since we wanted to use the width to the height, then we write that as the fraction, where it would be the width divided by the height. So as long as we know how to recognize those as being part of that figure, then we'll be okay. Now, since we're using ratios and we're using proportions, the idea is we want to use the same thing to talk about the ratio of the width and the height of the smaller figure. And so in this particular case, we're going to use the same strategy where width divided by the height. And so we're going to take 1 meter divided by, we're going to call it x meters. And so that would give us our other ratio. Now, if we look at the way that this is written down here, since it's just a little bit different, we have height and weight switched, but that doesn't make a difference. The idea with ratios is ratios can be switched depending on whatever our preference is. So since we're already given the template for our proportion, so we have figure A's height is 2 meters. The width for figure A is 4 meters, so I'll put that here at the bottom in this first fraction. So if you notice, this is all right here, this is figure A. On the other side, this is all figure B. So again, this is what we talked about before when we're maintaining consistency in order to create our proportion. Now over here, we have the height divided by the width, so we're going to do the same thing. So we're going to go the height, which in this particular case is 1 meter, and the width is our x meters. So we have don't necessarily need those labels, but you get the idea that we have 1 divided by x. Now, this is a specific case that I wanted to talk to you about because now it creates a situation here where we don't necessarily know what this is. Now, there is this process that you may remember from work with proportions in the past. We call this cross multiplication. So when you have a proportion, what you can do is you can multiply on a diagonal. And so with that multiply of a diagonal, what I'm going to end up doing is I'm going to multiply in kind of an X pattern, where I'm going to multiply these 2 numbers and I'm going to multiply these 2 numbers, and I'll put that in a different color so that you can see that. This is called cross multiplication. So you're multiplying a numerator with a denominator and the other numerator with the other denominator. And so what that ends up creating is it ends up creating a situation that looks like this. 2 times x is equal to 4 times 1, and so that still maintains our equality, but if you look, we still have a one-step solution. The only problem that we have here is that x is in the denominator, and there's no way that we can solve that by dividing by 1 or multiplying by 1 because it's on that side. We have to do something different, and so that's the way that we set this up. So we have 2x equals 4 when we simplify that, when we do that multiplication. And then just with a simple one-step equation, we can divide both sides by 2, and we get x is equal to 2 meters. So the idea is there's just a different way that you can go about this, but try to keep the variables in the top as much as possible because it makes things a lot easier. Now when we look at these other examples, it's exactly the same thing, but notice the only difference here is we're going to skip through this first one only because that's going to get taken care of when we do the other one. So I'm going to kind of cross this one out here, and we're going to just go ahead and do 6. So if Karen can ride her bike 10 miles in 1 hour, how far can she ride it in 2 hours? So we just need to set up our proportion. We need to set up our 2 different ratios. So the first ratio that we have is the known 10 miles for 1 hour. I can write that 10 miles divided by 1 hour, or I could write this 1 hour, 1 hour for every 10 miles. These two things mean the same thing. It just depends on where we want this variable to be. So we want to know how far, so that means that our distance is going to be x. Distance is miles, so it would probably be helpful to us if the variable was in the top. So we're going to keep that in the top here. So we'll have distance divided by time. So she can ride 10 miles for every 1 hour, and that should be equal to x number of miles for every 2 hours. Now, shouldn't take too much thinking to kind of understand that you're going to see where this is going. However, I can multiply both sides by 2 in order to solve that. And then we have 2 times 10 divided by 1, so x is equal to 20 miles. Now again, you should be able to look at that and say, well, if it's 10 miles for every 1 hour, then in 2 hours she's going to have 20 miles. So we can kind of jump to that conclusion there. So that's kind of finishing up and tying up our proportions and our ratios. Okay, so this is the part where we're talking about dimensional analysis, where we're trying to convert from a unit of seconds to a unit of hours. Now, if you think about this, the way that this works is that we're going to be using fractions and we're going to be using ratios, because conversions are just another way that we can use ratios. So when you convert, you use ratios, but the idea is that you're just multiplying the correct ratio. Now, it's going to matter on how we set this up and in what direction that we set it up, and exactly how and what we're trying to convert to. So seconds to hours. Now, there isn't a direct conversion from seconds to hours, but remember, we can move from seconds to minutes, and then we can move to hours. So we can use that kind of progression to be able to do that. Now, we will need a calculator for this, so if you have a calculator, you can get a calculator and you can go along with this. But the idea is that we want to take 7,500 seconds and convert it to hours. But first, we need to convert it to seconds. It's already there. Second, we need to convert it to minutes, and then we need to convert it to hours. Now, we can do this with ratios. Now, first of all, what we want to do is we want to set up our fraction. So we're going to set up 7,500 seconds. Now, that's not technically a fraction, so remember, to make a fraction, we just put it over 1. Now, as I said, we want to convert seconds to minutes. So we have to come up with a ratio that would say how many seconds are in a minute. And so one of the things that we can use, is I'll write this down here, is that there are 60 seconds for every 1 minute, or we can write it there's 1 minute for every 60 seconds. Now, both of these mean the same thing. They both have a ratio of 60 to 1, but it just depends on what one we're trying to convert to. Now, if you notice, we're converting seconds to minutes, and so what we want is we want the conversion that has minutes in the numerator. Now, what happens with this, if you remember from kind of your previous math classes, is that there's a thing called cross-canceling. Not the cross-multiplying that we just talked about, but the cross-canceling. The idea is that we want the seconds, the unit that we're trying to get rid of, to be in opposite areas, so one in the numerator, one in the denominator, so that we can eliminate that unit, and all that we're going to be left with is the minutes. So whatever we're trying to convert to, and I'll put that as a little note, must have converted units in the numerator. So we always want to keep our converting units to the numerator. Now, because I can start stringing these along, because this is just multiplication, this is not an equation in any way, I can immediately start to convert my next unit. So I'm going to multiply again, but now I'm going to convert minutes to hours. So there are 60 minutes for every 1 hour, or there is 1 hour for every 60 minutes. Now again, I want to get rid of minutes, so I want minutes to be in the denominator so that they will cancel each other out, and then hours at the top, so there's 1 hour for every 60 minutes. Now the idea with this is just like fraction multiplication. We multiply all the numerators together, multiply all the denominators together. So we have 7,500 times 1, which gives us 7,500. And then 1 times 60, which gives us 3,600. Now, because we're converting and because we want things to be simplified, we're going to take that fraction that we just multiplied and we're just going to divide those two numbers so that we can get a decimal answer for this. And so roughly in the calculator we get 2.08 hours. So based on our conversion and using our ratios and knowing that ratios can be flipped to whatever works for us, we allowed ourselves to be able to multiply these things together, use fraction multiplication that we've already done in the past, and put these together to give us our final answer of 2 hours and 2.08 hours in 7,500 seconds. Alright, so we're going to do a similar thing here. So it says a large adult male human has about 12 pints of blood, and we're going to use dimensional analysis to convert this quantity to gallons. So what we're going to do is we're going to start with what we're trying to convert to. We want to take pints and we want to turn that into gallons. Now if you don't know the direct conversion for that, what we need to do is we need to take this from pints to quarts and then to gallons. Now the idea is that there are 2 pints for every 1 quart, so we can flip that depending on what we need to, and that there are 4 quarts for every 1 gallon. So we can use those appropriately, whatever we need to, but remember, whatever we're trying to convert to always needs to go on the top. But this is going to be our procedure here. So the first one that we're going to write is we're going to write the fraction of our original, which is pints. So there's 12 pints over 1. And so we're going to multiply to do our first conversion. Our first conversion is going to do pints to quarts. So the idea is pints is here at the top, so pints needs to be down here at the bottom. So that means quarts needs to go at the top. Now if we use our handy conversion factor that we talked about over here, we're just going to use that in whatever way that suits us, so that there's 1 quart for every 2 pints, so this is going to be 1 divided by 2. So there's 1 quart for every 2 pints, or 2 pints for every quart. Now the next one that we're going to do is we're going to convert from quarts to gallons, so we're going to multiply by our next ratio, which is 4 quarts for every 1 gallon. And so again, quarts is at the top, so when we make our new fraction, quarts needs to be at the bottom, so that gallons can be at the top, so that we can make the proper conversion. So that there are 4 quarts for every 1 gallon. And so we have our conversion there. And so just like every other fraction, we're going to multiply those. So we're going to multiply all the numerators. 12 times 1 times 1, which gives us 12. And then 1 times 2 times 4, which gives us 8. So we have 12 over 8. Now if we reduce that, that gives us divide by 4, 3 over 2, which is 1 1/2 gallons, if we turn that into a mixed number. So the idea is that we're simply just converting based on what we know, setting up fraction after fraction after fraction to be able to give us the information that we need. Okay, so if we look at this modeling quantities, the other side of that sheet that you were given, the idea is that this section here at the top will show you how to set up those conversions so that we make sure that everything is correct. So if you didn't catch those in the notes that I gave you, you should be able to have these. Now there are a couple of things here that they want to go over here in order for you to know these things. So they want to know about feet and yards. So the idea is that conversion factors, if you notice what they're trying to show you, is that all of these will equal 1, and that's why we can use them however we want to. And so the idea is that we're going to be given a fraction with different numbers that don't technically equal 1, but they're showing you that they equal 1 because they are the same no matter what. Just like there are 3 feet for every 1 yard, those are the same. There is 1 meter for every 100 centimeters. And there are 8 fluid ounces for every 1 cup. So the idea is that these are conversions that you can look up that will be potentially beneficial to you later, but the idea is that we just need to make sure that we use these in order to make sure that we can convert to the right answers. Now, what I'm going to show you here is I'm going to show you two different problems here, but if you notice what's different about these is that these fractions, instead of having just one different type of unit, they have 2 different types of units. But we can still approach this the same exact way, we just need to make sure that we use this appropriately. And so the idea is that we want to convert this in terms of meters per hour rather than kilometers per hour. So the idea is we need to look up how many kilometers there are in a meter, because that's the only thing that we have to worry about. And so if we look this up, the idea is that there are 100 or 1,000 meters for every 1 kilometer. So that is our ratio that we're going to end up using. And so what we're going to do is we're going to multiply that in a way that is beneficial to us. Kilometers is here at the top, so we want kilometers here at the bottom. And so what we're going to end up doing is we're going to have our ratio of 1,000 to 1, so that there's 1,000 meters for every 1 kilometer. Now the idea behind this is that we're simply just converting this so that we can have those there, to understand that these things do equal 1 when we're trying to do that. So we're going to take these two numbers and we're going to multiply them. And so we're going to multiply this out. So 3,391.1 times 1,000. We're going to move that decimal place 3 times, so it's going to seem like a large number. So it's 3,391,100 meters for every 83.5 hours. Now all that we're going to do is we're going to try to get this in meters per hour, meaning that the bottom we want to have is what we call a unit rate, where the bottom or the denominator is always equal to 1, and so all that you have to do is you just have to divide those two numbers and you get 40,611 with some decimal places meters per hour, and I'll say 0.976. And so that's really all that you were having to do. Now it seems like a lot as far as entire meters though, but that's what we're asked to convert to, so we convert it. And so the same thing happens here, is that we have a soft serve ice cream maker that makes 12,000 gallons per hour. We want to make this into cups per minute. Now the couple of things that's going to happen here is that we have gallons per hour. So we're going to actually have to worry about converting 2 units at the same time. And as long as we set this up correctly, it shouldn't make too much of a difference. So first of all, they give us a hint that 1 gallon is 16 cups, so it makes that conversion a little bit easier. But also too that there is 1 hour for every 60 minutes. And so we can do the same thing that we did before, but just being a little bit more careful about that stuff, so that we can convert it correctly. So we're going to start off with our original fraction. So our original fraction in this particular case is 12,000 gallons, or 1,200 gallons for every 1 hour. So the first thing that we're going to try to get rid of is we're going to try to get rid of our gallons, and I'm going to put that in blue here. So to get rid of gallons, we need to use the 16:1 ratio. So I'm going to make my fraction here. So gallons is at the top, so I want gallons at the bottom, so I can get cups at the top. And so we know that there's 16 cups for every 1 gallon. Now the next one is, now what's going to happen is that gallons will cancel and we're left with cups. So right now, if I was to multiply this, this would be cups per hour, but I want cups per minute. So I'm going to multiply it one more time. This time I'm going to do this in black. multiply this one more time to convert from hours to minutes. Now hours here is at the bottom, so I want hours at the top and I want minutes at the bottom. So even though it was different before, now I'm making sure that I use my ratio to my advantage so that I have 60 minutes for every 1 hour. Now again, all I need to do is use my calculator to multiply those. So I'm going to have 12,000 or 1200 times 16 times 1, which gives me 19,200, and then 1 times 60, which is 60, and then all I have to do, just like everything else, is that divide this, and so that this is 320 cups for every 1 hour. And so that will make sure that I do my conversion correctly. So that's going to do it for all of this explanation. Now if you wanted to skip ahead through some of that or anything else like that, that would be perfectly fine. But the idea is that we needed to make sure that we had this all filled out so that we understand how to properly use conversions and do multiple conversions at the same time.